students. Today's topic is sedimentation. So, sedimentation is one of the important separation techniques used in food analysis, and it is the process of settling down of heavier insoluble particles from a mixture. And this sedimentation uses gravitational force to separate particulate material from the fluid stream. So, sedimentation is one of the most important separation techniques used in food analysis, and it is the process of settling down of heavier insoluble particles from a mixture under the influence of gravity. And this sedimentation uses this gravitational force to separate the particulate materials from the fluid mixture, and the particles are usually either solid or small liquid droplets, and the fluids we are using can be either a liquid or a gas. So sedimentation is the process of settling down of heavier insoluble particles from a mixture under the influence of the gravitational force, and the particles we are separating can be either solid or small liquid droplets, and the fluids can be either a liquid or a gas. And this sedimentation is very often used in the food industry for separating dirt and debris from the incoming raw materials, crystals from the liquor, and the dust or product particles from the air streams. And this is a diagrammatic representation of this sedimentation. We can see that in the second photograph, we will get clear water on the top, and the insoluble impurities are settled in the bottom. Next is the classification of the sedimentation process, and the first one is the type 1 sedimentation, and this process is characterized by the particles that will settle discretely at a constant settling velocity. Here the particles of the mixture will settle at a constant settling velocity, and these particles will settle as individual particles, and they will not flocculate or stick each other during the settling process. And examples are the such materials are the sand and the grit material. In the type 1 sedimentation, here the particles will settle discretely at a constant velocity, and that particles will not flocculate or stick to each other during the settling process. And examples are the sand and grit material. Next is the type 2 sedimentation, and it is characterized by the particles that will flocculate during the sedimentation. So in case this type 1 sedimentation, the particles will not stick or flocculate during the sedimentation process. But in case of the type 2 sedimentation, the particles will flocculate during the sedimentation process, and due to their constantly changing size, their settling velocity also changes. Examples are the alum or iron coagulation. So, in type 1 sedimentation, the particles will not flocculate or stick to each other, so that they will settle at a constant velocity. And in case of the type 2 sedimentation, the particles will flocculate during the sedimentation, and due to this flocculation, their size will change and influence the settling velocity, and so that the settling velocity will also changes. And the examples of such materials are the alum or iron coagulation. Next is the type 3 sedimentation, and it is also known as sound sedimentation. And in this process, the particles are at a high concentration and will settle as a mass. Here, in this type of sedimentation, the particles will be at a high concentration and they will settle as a mass, and a distinct clear zone and sludge zone are also present. Example is the lime softening, active sludge sedimentation, and the sludge thickening. So in case of the type 3 sedimentation, the particles are at high concentration and they will settle as a mass, and a distinct clear zone and a sludge zone will be obtained. And example are the slime softening, active sludge sedimentation, and the sludge thickening, and this process is also known as a zone sedimentation. So coming to the application, it is mainly used in the removal of the solids from the liquid waste, settling of crystals from mother liquor, settling of solid food particles from a liquid food, and also in the wastewater treatment. So the application are the removal of solids from liquid waste, settling of crystals from mother liquor, settling of solid food particles from liquid food, and also in the wastewater treatment. Coming to the advantages compared to other separation techniques, this sedimentation process is inexpensive, and also here the sedimentation occurs under the influence of the gravity, so that no extra energy is required. And then coming to the disadvantages of this process, this method removes only large solids from a mixture, and also it is labor expensive, and the cleaning also is very labor expensive process, and require more space and for the process, and also it do not ensure the complete removal of the solids from the mixture.